Hi, this is a quick look at using the Hamilton Paths Excel spreadsheet. It's an Excel SM, so macro enabled. If you don't know what that means, you don't have your developer tab up here, then go and watch the shortest path video in this series for explanations on that. I'm not going to run through all that again. Basically, how it works is this is a question off the 2022 WACE exam, the West Australian Certificate of Education, and it's the applications course. And the kids had to find something like the rubbish truck wants to go through, pick up all the bins and end up back where it started on this one. Now, in the spreadsheet, I've already got it set up in the adjacency or distance matrix here. So from A to B is 6. We can see from A to 6 here is A to B here is 6, and say B to C is 7. So B to C is 7. There it is. So basically, you can fill it up. Once you've sort of half filled the yellow and the top row of orange, you can use under the macros. There is a finish adjacency matrix option, which will copy everything from if I run it, then it just copies everything sort of above the leading diagonal to below the leading diagonal, but nothing changed because I've already run it. There's the last tab's got a couple of examples, the one we're looking at and the year before exam. So once you've got the adjacency matrix filled, then back to sheet 1, and this is where the magic happens. So make a blank adjacency matrix. That's covered in the shortest path. One again, how to set it up. But at the moment, we're starting at vertex 4. So let's change that and start at vertex 3, say. And cycles only, 0 is no, 1 is yes. So let's just get the paths as well as cycles. And vertices, do we want the listing of the paths to come out using, so here you can see vertex 1 is A, vertex 2 is B, vertex 3 is C, and so on. So we've got numerical or alphabetical tags. The code works on the numerical ones, but for ease, like in this question, you might want to use alphabetical. So back to the tab here, we're saying at the moment we'll go for number 1, which is numerical tab. So when we hit the old search button, it's done. And starting at vertex 3, let's see, we're on row 10. How many did it find? Scroll down, oh, quite a few. So there's over 100 different paths starting from vertex 3, which would have been C, around this. So that's where you kind of don't want that. The question is all about we've got to end up back where we started. So we want cycles. So let's say we want a number 1 here. And the actual problem was to start at vertex 1. So we'll start at vertex 1 now. And let's get the results out alphabetically. So we'll pop in a 0 in this box here. And everything's ready to go. We hit the old search button and off it goes. And how many has it found this time? There's still quite a few, but that's, what is that about? Just under 30, I think, because first one comes out on row 10 here. But the shortest one, there are 2 paths, Hamilton paths, which have got length 47 using the weights on the edges. So here's one of them and here's the other one. And that's basically how it works. The only other thing is there's to export the adjacency matrix. So that's just popped a copy of this adjacency matrix on my desktop. If I open it up now, here it is. So if you want to do more work with it, if we copy this, and then I'll just bring up my browser, and I think if we go to, what is it called? Graph online, graph-online.top. Then once we end up on this website, there is a create graph up here, and using adjacency, and we want to enter it as text. So if I just paste in our output there and then plot the graph, what do we get? Here it's a bit of a mess. Can we move any? Maybe if we pull this one out a bit and this one up here, we've got to try and untangle this one. Good luck, says Charlie, doing that one. But anyway, you might have to maneuver things around here a bit so that we can actually see it how we'd like to see it. But there it is, and so you can use it in other applications as well. And that's pretty much it. So that's, if I get rid of all that stuff, that's how it works.